Hello, and welcome to the third video of Fundamentals of Programming. I am Kalna Vijay Gunratna, and today we will look at program design and give you an introduction to symbolic design. This is the color coding we will be using throughout the presentation. Please take a moment to familiarize yourself with the colors. The approach to analyzing complex problems, planning for software development, and controlling the development process is called the programming methodology. There are several types of programming methodologies widely used, namely the procedural programming, object-oriented programming, functional programming, and logical programming. Let us take a look at procedural programming. In this approach, the problem is broken down into procedures or blocks of code that perform one task each. All procedures taken together form the whole program. It is suitable only for small programs that have low levels of complexity. For example, in a calculator program that does addition, subtraction, multiplication, division, square roots, and comparisons, each of these operations can be developed as separate procedures. In the main program, each procedure would be invoked on the basis of the user's choice. In object-oriented programming, the solution revolves around entities or objects that are part of the problem or the solution. The solution deals with how to store data related to the entities, how the entities behave, and how they interact with each other to give a cohesive solution. For example, if we have to develop a payroll management system, we will have entities like employees, salary structure, leave rules, etc., around which the situation or the solution, must be built. In functional programming, the problem or the desired solution is broken down into functional units. Each unit performs its own task and is self-sufficient. These units are then stitched together to form the complete solution. For example, again, in a payroll processing system, can have functional units like employee data maintenance, basic salary calculations, gross salary calculations, leave processing, loan payment processing, etc. Then there is the logical programming approach. Here, the problem is broken down into logical units rather than functional units. For example, in a school management system, users have very defined roles like class teacher, subject teacher, lab assistant, coordinators, academic in charge, etc. So the software can be divided into units depending on user roles. Each user can have different interfaces, permissions, etc. Software developers may choose one or a combination of more than one of these methodologies to develop a software. Note that in each of these methodologies discussed, the problem has to be broken down into smaller units. To do this, developers use any of the following two approaches: the top-down approach and the bottom-up or the bottom-up approach. As the name suggests, in the top-down approach, the problem is broken down into smaller units, which may further be broken down into even smaller units. Each unit is called a module. Each module is a self-sufficient unit that has everything necessary to perform its tasks. Hence, this approach is also known as the modular approach. Breaking down of a payroll processing system using a top-down approach is shown in the diagram. Notice how the payroll processing system is broken down into three modules, namely the get employee data, calculate net pay, and print payslips. Modules like calculate net pay are further divided into smaller modules like calculate gross pay, calculate deductions, etc. These small modules are needed to build the larger calculate net pay module, and in turn build the whole payroll processing system. In the bottom-up approach, system design starts with the lowest level of components, which are then interconnected to get higher level components. This process continues till a hierarchy of all the system components is generated. However, in real life scenarios, it is very difficult to know all the lowest level components at the outset of the project. So, bottom-up approach is used only for very simple problems. The diagram shows the implementation of a calculator using the bottom-up approach. Notice how very small functions, in this case operations, are combined to form higher level components like single input operations and double input operations. All these components combine to form the whole calculator. The first two steps of a typical software development process, that is, the requirement gathering and problem definition, assist the team in understanding the problem. Person responsible for gathering requirements, defining the problem, and designing the system is called the system analyst. Usually, clients or users are not able to clearly define their problems or requirements. They have a vague idea of what they want. So system developers need to gather client requirements to understand the problem that needs to be resolved or what needs to be delivered. Detailed understanding of the problem is possible only by first understanding the business area for which the solution is being developed for. Some techniques that help in this gathering of information are conducting interviews, distributing questionnaires, studying existing system documents, and analyzing business data. Some key questions that help us understand the business include: what is being done here? How is it being done? What is the frequency of this particular task? What is the volume of decisions or transactions happening in this particular arm or branch? What are the problems being encountered in the current process? And so on. System analysts need to create clear and concise but thorough requirements document in order to identify SMART or specific, measurable, agreed upon, realistic, and time-based requirements. If the analysts don't gather all the requirements or do an incomplete job, it could result in various problems. Incomplete problem definitions, incorrect program goals, rework to deliver required outcome to clients, increased cost, delayed delivery are some of these problems that could occur if the system analyst fails to do their job properly. Due to the depth of information required, requirement gathering is also known as detailed investigation. Problem definition. After gathering requirements and analyzing them, problem statement must be stated clearly. Problem definition should unambiguously state what problem or problems need to be solved. Having a clear problem statement is necessary to define the project scope, to keep the team focused, to keep the project on track, and to validate that desired outcomes were achieved at the end of the project. Coding is supposed to be the most essential part of any software development process. However, coding is just a part of the process and may actually take the minimum amount of time if the system is designed correctly. Before the system can be designed, a solution must be identified for the problem at hand. The first thing to be noted about designing a system is that initially the system analyst may come up with more than one solution. But there can be only one final product or solution. In-depth analysis of data gathered during the requirement gathering phase can help in coming to a unique solution. When faced with the problem of multiple solutions, analysts go for visual aids like flowcharts, data flow diagrams, entity relationship or ER diagrams, etc. to understand each solution in depth and help them select the best one. Flowcharting is the process of illustrating workflows and data flows in a system through using symbols and diagrams. Data flow diagram, or DFD, is a graphical representation of data flow through a system or a subsystem. Before the actual coding occurs, the basic operating principles, workflows, and data flows of the program are written using a notation similar to the programming language that the programmers intend to write in. Such a notation is called pseudocode. A real-life problem is complex and huge. If a monolithic solution is developed, it poses these problems: the difficulty to write, test, implement one huge solution, and the modifications after the final product is delivered is close to impossible. Maintenance of the program becomes very difficult, and one error can bring the whole system to a halt. To overcome these problems, the solution should be divided into smaller parts called modules. The technique of breaking one big solution into smaller modules for ease of development, implementation, modification, and maintenance is called modular technique, or programming or software development. Modular programming carries several advantages. Modular programming enables faster development, as each module can be developed in parallel. Modules can often be reused. Modular development enables independent testing that can be carried out concurrently. This makes testing faster and more robust. Debugging and maintenance of the whole program is easier when developed as separate modules. Modules are smaller and have lower levels of complexities, so they are easier to understand. A flowchart is a diagrammatic representation of sequence of logical steps of a program. Flowcharts use simple geometric shapes to depict processes and arrows to show relationships and process data flows. The basic symbols used to draw a flowchart can be seen in the table here. Take a moment to go through the table. When drawing a flowchart, make sure to remember that flowcharts can only have one start and one stop symbol. On-page connectors are referenced using numbers. That is, when a flowchart needs to be separated into two sections due to space constraints, but both paths are in the same page, reference the order of the connectors using numbers. If the two pieces of the flowchart are in two different pages, reference the connectors using alphabets. General flow of process is top to bottom or left to right. Arrows should not cross each other. Here are two examples of flowcharts. The first example shows a flowchart drawn to illustrate the process of calculating the average of two numbers. After the start symbol, you can see an input box taking two numbers and a process box doing the calculations. Finally, the flowchart ends with an end symbol after outputting the average in the output box. The next example shows a flowchart of a person going to the market to purchase a pen. You can see there are two parts of the same flowchart, and they are connected using a connector referenced by the number 1. This flowchart walks you step by step in the process of buying a new pen. Make sure to pause the video and have a good look at it. A finite set of steps that must be followed to solve any problem is called an algorithm. Algorithm is generally developed before the actual coding is done. It is written using English like language so that it is easy to understand even for non-programmers. Sometimes algorithms are written using pseudocode. It's a language similar to the programming language that is intended to be used. Writing an algorithm for solving the problem offers some great benefits like promoting effective communication between team members, enabling the analysis of the problem at hand, acting as a blueprint for the coding, assisting in debugging, and becoming a part of the software documentation for future reference during the maintenance phase. Some of the characteristics that you can expect from a good and correct algorithm include having a set of inputs, uniquely defined steps, having a finite number of steps, and producing the desired outputs. Here, you can see examples for algorithms for the problems that we saw earlier in the flowcharts. Notice how the second algorithm takes steps like the fourth step can be a complete and separate task all by itself. And a separate algorithm can be written just to explain that one step. It will be an important decision to decide to what level of detail you go into when writing an algorithm or drawing a flowchart. This depends mostly on who will be referring them later and for what purpose. With that, we come to the end of this session. See you in the next video.